Hi! So in this mini lecture we will learn to judge which alkenes are the most stable. So first of all, because of steric strain, cis alkenes are generally less stable than trans alkenes. Let's look at an example. Let's look at 2-butene to see why this is the case. So this is 2-butene. And I've drawn the trans diastereoisomer. So in the trans form, as you can see here, the two methyl groups are far away from each other. Basically, they are on opposite sides, opposite ends of the molecule. And so therefore, the trans isomer contains very little steric strain. Now let's look at the cis isomer. Here the methyl groups are on the same side of the double bond. And so they really collide with each other. Okay, and so there's a lot of steric strain there between those two methyl groups. You can see that even better in the space filling model shown down here underneath. Basically, there you can kind of see that the two hydrogens attached to the methyl groups bump right into each other in the cis isomer. So next, let's examine how the number of alkyl substituents on an alkene affects its stability. So in general, alkyl groups actually stabilize carbon-carbon double bonds. And they do this with hyperconjugation. And remember hyperconjugation from carbocations. It's essentially a process where we have like sigma bonds donating electron density into a pi system. So the pi system in the case of a carbocation is just the empty p orbital of the carbocation. In this case, it's the double bond of the alkene. Right? So this means the more alkyl groups we have, the more stable an alkene is. So on a scale of increasing stability, here shown in blue, we have the least stable alkenes being mono-substituted ones, and then di-substituted alkenes are more stable, followed by tri- and tetra-substituted ones. Okay, so all you have to remember here really is that the more alkyl groups an alkene, the more alkyl groups are attached to an alkene, the more stable it is. So I recommend that you practice this skill with conceptual checkpoint 7.16 in your Klein textbook.